All right, guys, this is the second part of section 8.5. So what we're going to be doing here is we're given either a recursive or an explicit rule, and we're going to write it the other way. So if we're given an explicit, as we are here, we're going to write it recursively. If we're given recursive, like we are down here, we're going to write explicit. So I don't know that I need to do all of these with you, but I am going to do a couple. We'll see how it goes. All right, so in this first one, if I want to find the first term, I plug in 1, I'm going to get 2. If I plug in 2, 5 minus 6 is going to give me -1. And now you can probably see this pattern developing here. This would be our pattern. If I'm writing a recursive rule, I always have to state what a sub 1 is. So in this case, a sub 1 is 2. And then to write a sub n, I have to write it like this. I'm going to say it's going to be a sub n minus 1, and then I can see what's happening every time is that I'm just subtracting 3 from whatever that previous value is. So if I want to check this, I can say a sub 3 should be equal to 3 minus 1 is 2, a sub 2, which is this, minus 3, and it is. And we could check that over and over again if we wanted to. All right. So to get the hang of this one, this is a geometric sequence. I might want to write it out. If I plug in 1, anything to the 0 power is 1 times 10 is 10. My next term, I can plug in 2, -2 to the first, so that would be -20. And I can see here that this is actually just giving me a sub 1, and then this is my r value. Excuse me. Multiply by -2 again if you want, and this is our pattern that's developing. So recursively, I have to state what a sub 1 is, and then I have to say a sub n is going to be the previous term times, in this case, -2. So I might want to write that as a sub 1 equals 10. A sub n is going to be equal to -2 times a sub n minus 1. That'd be a little bit better than the other way. All right, and so then I could check it. If I wanted to find the fourth term, a sub 4 would be a sub 4 minus 1 is 3, a sub 3 times -2, and that works. All right, so see how easy this can be. And you're going to see some patterns where you can probably make some generalizations about this, but I'm going to just keep kind of doing it this way. So on this one, if I plug in 1, my first term, -1 plus 8, is going to be 7. If I find my second term, -1 plus 16 is going to be 15. And then I can see here that my 8 is going to be my d value. So I would just keep adding on 8 over and over. So to write this recursively, I have to state a sub 1. And then a sub n is just going to be equal to that previous term plus 8. All right, so pretty easy, right? All right, one more. I can see that this is in my geometric form, so I know this has to be a sub 1. And I know this has to be my r value. So I can say a sub n is going to have to be equal to 3/4 times a sub n minus 1. I can go directly there. Now, if you have trouble going from here to here, then just write it out like we have been. All right, so now we're going to be given the recursive, and we have to come up with the explicit. So again, maybe it helps to write it out. There's my first term. I'm supposed to add 7, add 7, add 7. That's my pattern. And now I have to come up with the explicit rule. Well, I can see this is going to be an arithmetic sequence, and I'm adding on 7 every time, so it has to be 7n. And then to get this to work, I would have to subtract 8. Now, I might want to check it maybe for the fourth term. 7 times 4 is 28, minus 8, 20. Great, it works. There we go. All right, let's try the next one. So this says my first term is going to be 24, and then the next term, a sub n plus 1, meaning a sub 2, if I want to let n equal 1, is going to be equal to a sub 1 times 0.2. So I'd have to do 24 times 0.2, and that would be 4.8. And then I'd have to take that times 0.2. I'm just going to use a calculator to be sure. 0.96. Okay, so we can see what's happening here. Every time we're multiplying by 0.2. Well, This is going to be geometric then. So it's going to be a sub n equals a sub 1 times r to the n minus 1. And then I might want to check that out just on that third term. So if I'm checking this third term, n would be 3. 3 minus 1 is 2. 0.2 squared is that times 24 should give me that. And it does. So we're good. Okay? Maybe you should try the next two on your own. Pause the video, try them out, see if you get them right. I'll do them up here. All right, so what I did was I could see that I was going down by 0.3 every time. In order to get 1 here, I'd have to add 1.3. Another way to do this is to use our formula, a sub n equals a sub 1 plus n minus 1 times d. That's our arithmetic form. If you don't want to mess around with trying to figure this number out, you just plug in a sub 1, n minus 1, d is going to be negative 0.3, and then you have 1 plus negative 0.3n plus, and then negative times negative is a positive 0.3, and see how we're going to get negative 0.3n plus 1.3. Okay, so same thing. All right, this one is geometric. Very easy. Our formula is a sub n equals a sub 1 times r to the n minus 1. So hopefully you got it. It's going to go negative 2 times. Now it's just a good habit to put that r in parentheses anytime you write it. See how I always do that? And then to the n minus 1. Otherwise people might think you're multiplying those and then doing to the n minus 1.